We spent some time analyzing two-dimensional collisions yesterday with funny angles. We had a bit of a tough time with that. That's okay. We're going to spend some more time on it today to follow that up and hopefully end today on a little bit better note than we ended yesterday. Let's take a step back for a couple minutes though, okay? Let's go back to those one-dimensional problems where we had two objects colliding on the same axis, on the x-axis. We could analyze that problem using pi is equal to PF. And we would say again, M1 V1I plus M2 V2I equals MVF, or M1 V1F plus M2 V2F, depending upon how many objects you had both before and after the collision. We could do that, right? No problem. Usually we end up solving for VF there, although we saw yesterday that we could have solved for maybe VI, maybe V1I, V2I, whatever the case may be. It doesn't really matter which variable you're solving for. In the end, okay, it's almost always going to be a velocity that you're solving for. Well, we know how to solve the problems that are on the other axis as well, the vertical axis. If you have two objects colliding, one's going north, one's going south. We got, once again, PI is equal to PF. And typically in this case, we'd solve for VF again. Although maybe it's going to be V1I, maybe it's going to be V2F or V1F or V2I or whatever, but whatever it is that we're trying to solve for, we've got a velocity. Got it? You guys have solved a bunch of those problems. You guys are good at those problems. Okay, we had a quiz on that a week ago, and you guys did well on that quiz a week ago on one-dimensional collisions. So yesterday, we extended this a little bit to two-dimensional interactions. Like maybe we had a situation, sorry, not yesterday, a couple of days ago, we extended that to a situation where maybe we had an object going this way, and we had an object going this way. We knew pretty much right away when we saw a question like this that we had to break it up into x components and y components. We'd say for our x component, pi is equal to pf. And we'd solve for usually the final velocity. In other words, what we just did with the x component in this problem amounted to the exact same thing we did with the problem where there was only an x component. If there was something on the y-axis here, like there is with object number 2, then we completely ignore it when we're analyzing the x component. It doesn't exist as far as we're concerned. For the y component, we're going to do the same thing as we did in the second problem over here, except that we have to ignore everything on the x component. So we end up solving usually for VF, and then, look, we've just done no more, no less than we would have done in question number 1 and in question number 2. But there is a third part to this, and that is to combine these two. So instead of just saying, oh, okay, I got VF for the other one, I'm going to combine the two VFs, and it's going to look something like this. The resultant being from start to finish, use the Pythagorean theorem in the inverse tan function. I think you guys are pretty good at this. I don't think you guys need a whole lot of help at what I just showed you, what I just reviewed with you. Here's what I want to do now, though. I want to change this problem into this problem. Object number 2, we'll say, is still going downwards, but object number 1 this time is going downwards as well at a funny angle. Let's make it 30 degrees. Let's make the velocity of object number 1 10 meters per second. It's mass. We're not going to worry about that because we're not actually going to solve this problem. What do we do? What makes this different than the problem that we just saw on the last page? If the problem was like this, then we would simply say pi equals pf twice. If the problem's like this, then we're simply going to say pi equals pf twice. It's the exact same thing as far as that goes. The trick here is that we have a funny angle that we have to deal with. And how do we deal with that? Let's go off to the side. Okay, let's go off to the side and get rid of it. So down here, we're going to say I got a 30-degree angle. And that 30-degree angle with 10 meters per second is going to turn into an x component and a y component. Let's say for the x component, because it's the adjacent side, cosine 30 degrees is equal to adjacent over hypotenuse. X ends up being equal to 8.666 meters per second. For the y component, let's say sine 30 degrees is equal to opposite of hypotenuse. So y is equal to 5 meters per second. You with me there? All I've done is taken this 10 meters per second and gotten an x component and a y component for it. Now what I like to do is get rid of this. You don't have to, but my suggestion is erase that whole thing or redraw that whole thing. Replace that 10 meters per second with 8.66 meters per second. And the y component was 5 meters per second. Now, when I'm subbing numbers into this, I'm not going to sub in the 10 meters per second. I'm going to sub in either the 8.66 or the 5. Here we say M1 V1I plus M2 V2I equals MVF. Solving for VF. V1I here is 8.66. V2I is drop everything that's on the y-axis. V2I is 0. And then you solve for VF. Do the same thing almost with the y component. We'd say M1 V1I plus M2 V2I equals MVF. V1I this time is -5. 5 downwards, right? What's V2I? Whatever it is, right? Not 0. There's a value to it now. Let's look. You get this far, plug in numbers and solve, right? Does it make a little bit of sense? Does it seem to make a little bit more sense than yesterday? Now, when we go to actually do a problem, sometimes it's like, okay, it doesn't make quite as much sense as when we're just reviewing. But I think it will. Yeah, I think it will. Sometimes we just need that. We just need that night away from it, to step back from it, and come back with a fresh mind and tackle it again here. Let's do a problem. Okay, let's do a problem that appears in your multiple choice / worksheet booklet. It's going to be somewhere around page 15. The context of it is a game of curling. So the red curling rock traveling straight down a sheet of ice at 0.36 contacts a stationary blue curling rock. After contact, the blue rock moves at 0.14 and then goes 67 degrees. The red rock moves and then goes 23 degrees. As illustrated, the mass of the curling rock is 18.8, and we want to find the speed of the red rock. Pretty clearly, I think this is a conservation of momentum problem, right? Because it's a collision. And I think it's pretty clear that because we have some funny angles, there's an x and y component involved here. We can't just say pi equals pf. We've got to say pi equals pf twice for the x component and the y component. And I also think it's pretty clear that we have to do something before we do the x and the y component. What is it that we have to deal with first? Right away, we want to take off to the side and do what?
I don't like funny angles.
Don't like funny angles, so let's get rid of that 67 degrees. Hey, listen, we have two funny angles here, right? 67 and 23. We can't do anything with the 23. How come? Well, we're trying to find how fast this red curling rock is going to go. Yeah. Bottom line is we don't know the hypotenuse, right? We don't know anything else about that triangle. So take the 23 off to the side if you want, but it's not going to help you because you're not going to be able to get anything from it. Here's the bottom line. If you have an angle, but you don't know the hypotenuse in one of these questions, don't worry about it. Just pretend you don't even have it. So as far as we're concerned, that 23 degrees, we don't even have it. Later on, I will show you a shortcut, actually, that you can follow with that 23 degrees, but I don't want to confuse you with a shortcut right now. Just pretend you don't have it. So let's take the 67 degrees off to the side here. 67 degrees measured right here. from an x-axis and a y-axis. The magnitude of that hypotenuse is 0.14 meters per second. We want to find an x component and a y component. The x component is the adjacent side, so we're going to use cosine. And the y component is the opposite side, so we're going to use sine. Connor, 0.12887. Okay, thank you. What's the x? Okay, thank you. You guys agree with those? Yep, good. All right. So we've done it. We've taken care of our funny angle there. We don't have to worry about that anymore. In fact, I think I'm going to replace it. I'm going to replace it with a 0.0547 this way and 0.12887 this way. And now, just like that angle that I scratched out a minute ago, I'm going to scratch out this. Doesn't matter anymore. It's gone. We'll call this object number 1. We'll call this one object number 2. So let's do our x components and our y components here now. We're going to say pi equals pf. How many objects do we have before this collision takes place, Noah? Megan, how many objects do we have before it takes place? How many curling rocks do we have before this collision takes place? Matt? 2. All right, we got a red rock and a blue rock. M1 V1I plus M2 V2I equals, they don't stick together, do they? M1 V1F plus M2 V2F. Oh, look at this. Just spotted something, a little bit of a shortcut here that we don't have to be incredibly observant to notice, but just a little bit observant. Maddie, what's going to be? We got the same mass. That means we can cancel out the mass in every term. What's V1I? 0.36. It's all on the x-axis. What's V2I? All right, so let's just get rid of that whole term. What's V1F? What's V1F for the x component? Look at the picture up here. Now, what's V1F? 0.0547. Right? What's V2F? We don't know. Do you see what I've done there? Do you see what I've done? That angle, 67 degrees, that speed, 0.14 meters per second, is gone. It's replaced with 0.05 and 0.12. I need the 0.05 this time because green is horizontal for me. When I go to the other one, the y component, I'll use the other one, the blue one, because that's the y component. V2F works out to be 0.36 minus 0.05, 0.31, 0.3053. Now let's do the y component. Pi equals Pf. M1 V1I plus M2 V2I equals M1 V1F plus M2 V2F. Maddie, masses still cancel, right? Still the same masses. What do you notice about the x component, though? What's V1I? Look at object number 1 before this collision takes place. How much of that 0.36 is on the y-axis? Ian? How much of that 0.36 is going up or down? Yes, you do. How much of that 0.36 is going up or down? Look at the picture. None of it. 0. Right? This one's not moving at all, so the total initial momentum is 0. What's V1F? What's V1F? Okay, object number 1. I think I got V1F and V2F mixed up here, didn't I? Yeah, I think I did. This should have been, yeah, not a huge deal. V1F is what I'm looking for. V2F was 0.0547, which meant that V1F was this value, right? For this one, V1F, we don't know. Red curling rock, we don't know. So we're trying to find V2F is going to be what? V2F, Spencer, what's V2F going to be? The blue curling rock, Y component after. Good. So I had the right numbers. I just was calling it the wrong variable. Look at this. We've got X and Y now. Now it's easy. Okay, now it's easy. Now it's physics 20 stuff. All we got to do now is say, I got 0.3053. I got 0.12887. Let's find the hypotenuse. And we're going to do that by the Pythagorean theorem, and when I do, I end up getting C, 0.33. Does this all of a sudden seem easier than yesterday? I hope so. I hope so. In the end here, look at the colors. Okay, look at the colors that I've got. The colors are the only thing that separate what we did 3 days ago from what we did yesterday and today. The colors are what relate to the funny angle. Okay, the colors replace the speed that we have with an X component and a Y component. And I've color coded it so that you can see where I plug in those components. All right, here's what I would like you to do now, please. Open up your worksheet booklet, and I would like you to take a look at question number 7 in your worksheet booklet on worksheet number 4. Take a look at it. Draw the picture out. Okay. Understand when we've got a funny angle, what we got to do with that funny angle. Okay. Clearly, and in a structured way, replace X and replace the vector at a funny angle with an X and a Y component. Work through that for the next few minutes, and we'll see how that goes, and then we'll make a decision about what you're going to have for homework tonight.